There is an industry that didn't exist in its current form 10 years ago, that now influences more capital allocation than oil, more consumer behavior than social media, and more geopolitical tension than most military alliances. An industry where a single model release can add $200 billion in market value in 48 hours. Where a small number of companies control the compute that determines who builds the future and who rents it. Where training a frontier model now costs over $100 million and rising. Artificial intelligence. Not the concept, the industry. The one quietly absorbing the smartest engineers, the largest data sets, and an increasing percentage of global GDP, while most people are still thinking about chatbots. This is what nobody tells you about working inside it. From the first line of code, to the rooms where models are decided, to the level where you stop building intelligence and start deciding who gets access to it. Level 1. The entry-level engineer. 22 years old, $140,000 base, $40,000 signing bonus. You just graduated from Stanford, MIT, or Carnegie Mellon. You didn't study AI directly. You studied the pieces, machine learning, statistics, systems. You join a company like OpenAI or Google DeepMind. At first, it feels simple. It isn't. Your first week, you open a data set that doesn't feel real. Terabytes of text, broken labels, duplicated samples. At 1:32 a.m., you fix a small issue. Nothing breaks, but the model stops making a specific error. You notice. No one else does. Small data changes move behavior more than architecture ever will. You write pipelines, clean inputs, fix edge cases. You think you're building intelligence. You're not. You're shaping what it learns from. Level 2. The applied ML engineer. 26 years old. $210,000 total comp. Over time, the models stop being experiments. They start running. At scale. Latency matters. Cost matters. At 11:47 p.m., you push a change. You quantize the model. 32-bit to 16-bit. Speed improves. Cost drops. Accuracy barely changes. The dashboard refreshes. You just saved the company millions. No message. No announcement. You close the tab. This is where the job shifts. The product isn't intelligence. It's efficient intelligence. You still think better models win. Not always. Sometimes the cheaper ones do. Level 3. The research scientist. 29 years old. $300,000 to $500,000 total comp. You move away from the product back to research. Slower, quieter, less certain. Months pass on ideas that don't work. Then one run does. At 2:13 a.m., the metrics shift. A small change in attention routing. 5% better performance. 30% less compute. You rerun it. Same result. You sit there for a second longer than usual. Now it matters. Training costs are massive. You didn't just improve a model, you made it cheaper to build. The paper gets attention, not because it's elegant, because it saves money. Up to this point, the work makes sense. That's about to change. Level 4. The senior engineer, or tech lead. 32 years old. $450,000 to $700,000 total comp. You don't just write code anymore. You decide what gets built. Your team is 12 engineers. Your decisions affect hundreds. You sit in a meeting. The question isn't, can we build this? It's, should we? The benchmarks look strong. The red team report doesn't. Edge cases. Unpredictable outputs. You raise concerns. They are acknowledged, then quietly deprioritized. Because somewhere else, a company like Anthropic or Meta is moving faster, and whoever ships first defines what becomes acceptable. You thought better systems meant better outcomes. Not always. Sometimes they just mean faster ones. Level 5. The engineering manager. 36 years old. $800,000 to $1.2 million total comp. You manage people now. The technical problems were easier. At least they had answers. Your best researcher wants freedom. Product wants deadlines. Leadership wants defensibility. At 9:40 p.m., you review a rollout plan. 1% of users, then 10, then everyone. You pause, just for a moment. You're not fully comfortable. You approve it anyway. Nothing breaks. That doesn't mean it's safe. You learn something here. You don't get rewarded for being right. You get rewarded for shipping. You are no longer solving problems. You are deciding which risks are acceptable. Level 6. The Director of AI Systems. 42 years old. $2 to $4 million total comp. By now, the scale stops feeling theoretical. It becomes operational. You oversee entire systems, budgets in the billions. You don't request compute, you negotiate for it. Because companies like NVIDIA define your limits. A training run begins. $80 million. Thousands of GPUs, distributed across clusters. If synchronization fails, everything resets. Halfway through, loss spikes. No one speaks. Then it stabilizes. Barely. You don't react. You move to the next step. You are no longer building models. You are deciding where intelligence goes. Level 7. The Vice President of AI. 48 years old. $8 million to $15 million total comp. You spend less time with engineers, more time with governments. AI is no longer a product, it's infrastructure. You define access, API limits, rate caps, capability tiers, who gets what, and who doesn't. You sit across from policymakers. They ask, why not open everything? You explain risk. They ask, then who decides? You pause, because there is no clean answer, only trade-offs. This is where control starts to feel unclear. Level 8. The Architect of the System. 54 years old. $50 million plus net worth tied to equity. You don't think in products or models. You think in timelines. 5 years, 10 years, 20. You've seen systems that aren't public, models that were trained and never released. Not because they failed, because they worked too well. You sit in a room, a decision is being discussed. Not technical, timing. When to release, when to wait, when to hold something back. You realize something. Control is temporary. Progress isn't. And the question that matters now isn't, can we build this? It's, what happens after we do? Closing. The system that trains itself. Somewhere right now, in a data center, thousands of GPUs are running, training, adjusting, learning. At 2:13 a.m., a junior engineer is watching logs. A system they helped configure is evolving, quietly. Tomorrow, a new model will be announced. It won't feel sudden. It won't be. It will be the result of thousands of invisible decisions, some optimizing cost, some chasing performance, some accepting risk, all contributing to something that is becoming harder to fully understand, even for the people building it. The system doesn't stop. It just gets new people, at different levels, with different understanding, all stepping into the same machine, thinking they are building intelligence. They're not. They're learning what it costs to run it, and they only understand that after they're already inside.